Yes, I'm ready.
Okay. Hi everyone. This is Sam from New Smart Economy. Today we are glad to invite Audrey from CryptoZombie. Recently, CryptoZombie create a new course about how to develop smart the projects on you. So, Audrey, maybe you can introduce yourself first and start your workshop then.
Sure. So, Sam, thanks for the introduction. I'm happy to be here. If you don't mind, I will start with a few words about crypto zombies to give everybody a bit of context. So we launched the so crypto zombies is an online coding schools that aims to teach you everything you need to know in order to build smart contracts and the apps. We started a few years ago, and we were initially focused on EVM and Solidity, but over the last 1 or 2 years, we noticed that there is a strong interest for other technologies and blockchain. So we started expanding building courses for blockchains like Dio, for example. Yeah. Our website where you can take the course is cryptozombies.io. When you type this in your browser, you will be presented with a landing page where you will have to choose the courses from the top navigation bar, and then you will choose Neo to start the Neo course, and then click the Start Now button. There's one thing I would like to mention before we delve into the course itself is that the platform gives you the ability to create an account and to sign in. This is not required. It means that you can just you can complete the course without having an account. But in this case, your progress will be stored in the browser's local storage, and this means that when you will use the different browser or a different device, your progress will not be synchronized. Yeah. Now, that being said, here I'm not logged in. I will start by giving you a brief overview of the Neo blockchain. I mean, I'm not sure that, so I'm sure that everybody is already aware of the advantages of building on Neo, but I would like to highlight just three of them. And the first one is that the platform, the blockchain is highly scalable, and it allows you to perform large number of transactions per second. Then the platform takes a proactive approach to compliance and regulation, which makes it ideal for businesses and enterprises, where it can coexist with the existing system. And as a technical person, probably the part that I like the most is that it supports multiple programming languages like C Sharp, Java, and Python, which obviously makes it accessible to a large number of developers, and it doesn't require learning curve. Yeah. That being said, in this course, we will focus on two things. On so the main focus will be to teach you how to interact with the Neo name service, which is a distributed and open name service which runs on top of the Neo blockchain. And to do this, we structure the course into distinct parts. The first part will teach you how to do this by building a smart contract in C Sharp, and the second part will be CLI based, which means that you will build a client in Node.js that will interact with the Neo name service. Okay, so first The next step is to delve into the actual content of the course, but I would like to ask you how it is best to go about the questions that you probably or you might have. So should we have like 5 or 10 minutes at the end of the workshop for questions and answers, or do you just want me to stop after each lesson or each chapter? How is best to go about it?
I think you can first introduce the chapter first, and at the end, if there is any questions, you can answer them all in one time, I think.
Okay, cool, awesome.
Great.
So for yeah, so just to give you an overview of the UI for each chapter, we have at the left part of the screen, we have the concept information that teaches you what you need to know to complete a specific task. And at the right side of the screen is the part where you will actually have to write code, or in other chapters, you will have to enter a command in the terminal later. We'll get to that a bit later in the course, yeah. So to start, the first thing that you must consider when you are building smart contract on top of Neo are the concepts of classes and inheritance. And this is kind of the starting building blocks of every application on the smart contract you build on top of Dio. And this leverages the C# programming language, which comes with a number of benefits like safety and reliability, and also you will benefit from from a large number of tools that are already developed for the C# programming language. And just to give you more context about how this chapter is structured. So after we present the concepts that you learn in each course, we usually provide an example. Like for this course, we show how you declare a class. I mean, I didn't mention at the start of the workshop, but this course assumes that you have some basic knowledge of programming, and it is even better if you have some knowledge of C#. It's not required, but knowledge of C# is highly recommended to complete this course. Yeah, but uh, for each of the chapters, we do provide an example, which makes it easier for you to understand the concept itself and to provide the right answer here. Yeah. And after we do this and we explain the example line by line, it's your turn to write code, which means that you have to move to the right part of the screen. And in this chapter, for example, you will have to declare a public class named NNS client that inherits from a framework.smart contract. And I will, let's say that, for example, I make a typo here. I will want to show you one of the features of the platform. So it's a public class and as clients that inherits from framework. Sorry for the typo. This was not intended. You see, we also have a code completion here. Okay, so we have a typo here. When I click the check answer button, it will highlight it here. You see. So I fix this. I click try again, and I have the correct answer. So I would like to stop here for this chapter and see if you guys have any questions so far before I move to the next chapter.
I think there's, yeah.
Okay. I guess there are no questions, but anyway, you can ask them at the end of the workshop. So once we declare the work class, the next thing is to understand how we can save data and persist it on the blockchain. And for this, Dio offers an object that is called the storage map that essentially allows you to store data as a key and values. Yeah. And one other thing that you must take into consideration when you store data on the blockchain are the visibility and the security of the data, which can be defined using role and access modifiers. I will not go through them in this brief workshop. They are explained here. And for example, you have public, private, and protected. And and in a similar fashion as in the first chapter, you will have to write the code here on the right side of the screen. And yeah, we always add a comment to make it easier for you to find where the code needs to be added. One other trick that I will want to show you here. Oh, sorry, I moved by mistake to the first chapter. If you don't know the answer, you can just type, you can just click show me the answer button. And it will show the complete code and the part that is missing that you have to type. It's highlighted in green here at the bottom, yeah. For example, if I copy paste it, I click try again, I have the correct answer here. Okay, and any questions so far?
I think no so far.
Okay, cool. So in the third chapter, we will start showing students how to actually invoke method of the NNS smart contract. So for this, we will need to know and store something called the script hash of the NNS smart contract, which is kind of a unique identifier of the contract, which is calculated by hashing the compiled bytecode representation of the contract. I will not delve into the technical details, but we provide the value here, and this needs to be stored using something called an initial value attribute that allows you to specify a value for a specific palm for a specific field. Sorry, and again we give an example here which is closely related to what you will have to enter in this lesson, and it's explained, and then it's your turn to write the code in the right side of the screen. Yeah, so essentially you have to add initial value attribute, which is similar to this, and then to declare a variable named NNS hash. Yeah, I'll move to the next chapter. So once we have stored the hash of the contract, the next thing that we will do is to use the contract.call function to invoke method of the smart contract. So this takes few parameter like the script hash, the name of the method, the call flags, and the parameters. They are all explained here in the course, and we also provide an example of how you call a method. Of course, it's not identical with the answer that you will have to enter. Like for example, we used my method here as a dummy name for the method, and for your part, you will have to call the register method of the Neo name service. This will register new domain name with the NS. Yeah. Again, you can type the answer here in the right side of the screen, or if you don't know the answer, you can just ask the platform to help you out. Okay, are we good so far? Do you have any questions?
No, for
Okay,
now.
I'll move
Yeah,
to the next.
yeah.
Okay, so I so I will move to the next chapter then. So one of the nice things about Neo is that when you deploy a contract, it allows you to initialize its state and set up the storage, and this is done through a function named deploy. This is the signature of the function. It takes two parameter, data and update. Data is an object that you will pass when you deploy the smart contract, and update is a boolean value that indicates if this is the first deployment or if this is an update. Yeah, so when you update a smart contract, this parameter will be set to true. Yeah, so just in order to make sure that you perform a certain logic only when a contract is deployed, you will have to check the value of this parameter as is shown here. Yeah, and when it's true and we are updating, it's not deployed, you can return or perform some other step if you wish. Yeah. And one other thing that we do when we deploy the smart contract, it's to store the owner key and the owner in the contract storage. I will not type the code. I mean, it's so long and I want to be brief, but essentially the code that the students will have to write, it's can be seen at the right side of the screen. Okay, and the next chapter is mostly related to updating the smart contract. Like I said, there are different, you can perform a different set of steps when you deploy a smart contract, and some other steps when you update the smart contract. And for example, I mean, you may ask, why would you want to update your smart contracts? I mean, some good examples are when a bug has been found and you want to fix it, or you want to add new feature, or you want to just make some improvements or optimize the performance of your smart contract. I mean, there can be many use cases, and this is a very nice feature to have. Yeah. So we explain how the app how the update works, what are the parameters that are required. It's the nav file, is the manifest, and the data. They are all explained here. I will not delve into details. And one of the things that you must ensure when you are updating a smart contract and you are executing some logic is to ensure that only the contract owner can perform these steps. Yeah, so this is the reason why in the previous chapter we store the address of the contract owner in the contract storage here. Yeah, you see. So now when you update, you make sure that the contract owner has invoked this function. Okay, so I mean, this was all related to interacting with the NS smart contract from smart contract written in C#. I mean, this gives an introduction and explains all the concepts that you need to know to build a smart contract for your the app. And I would like to stop a little bit here and make sure that you have any questions or if there's anything else that maybe the DO team would want to add before I move to the next lesson that is focused on building a CLI-based client.
Yeah, for now, I haven't seen any questions in the chat room, so maybe we can move forward. And I think audience, if you have any questions, you can type it in the chat room, and our guest will answer it.
Yeah. Also, I can answer question after the course of line. If you can send them to the Demo team, they will forward them to us.
Okay.
Yeah.
Okay.
Okay. So, in the second lesson, I will show you how to build a Node.js application that is essentially a CLI client that you can use to interact with the GeoName service. And the first thing when you build a node, when you build a node project is to initialize the project. For this course, we will use Yarn, so I will not go into the details of what Yarn is and how it works and so on and so forth, but I would like to mention that for this CLI, we will mainly use two libraries. One is City of Zion's excellent Dion.js that allows you to interact with the Neo blockchain, and it provides all the functionalities that you need to invoke the methods of your smart contracts to send transaction or just query query the data. And the other library that we will be using is the commander. I mean, it's a pretty simple. I'm not sure if everybody is aware or is familiar with the commander, but it's kind of easy way to build the CLI with Node.js. Okay, as I mentioned in the first lesson, in the right side is the part where you have to enter your answer. Now, this is a little bit different because here you don't have to write code, and actually what you see here it's a terminal emulator when where you will have to enter a command. So the first command that you will have to enter, I think it's here in init, if I'm not wrong. Oh, sorry, it's the wrong answer. So what you have to do when you type the wrong answer is to type help. Okay, so you need to pass some parameter to Yarn to make it easier. So the just flag, it won't prompt you to. It will not ask you a set of questions, and won't prompt you for the answer. It is explained here. Yeah. Okay, so it run yarn, and the second command will be to install the City of Zion Neon.js, and the third one to install the commander. I will not go through this. I mean, they are similar. You just have to enter yarn add and the name of the library. Yeah, and I will move to the next chapter. Here we added some boilerplate code. If you take a look at the right part of the screen, we store the hash of the neo name service and the URL and the private key. We will read them from the environment. I mean, it's not a good idea to store them in your source file because you can commit them to GitHub, and once your private key is exposed, you are at risk of losing all your assets. So one way to prevent this is to store the private key as an environment variable and read it. And the first thing that we want to do here in the second chapter is to import the required modules to build this CLI based client. And for this, we will use something called named imports. Yeah, this concept is described here. So essentially, you can specify the name of the entities, which can be a variable, a function that you want to import from a module. So you don't have to import the whole module, you just import the relevant part of it. Yeah. And we also give an example, like you've seen in the previous chapters, and at the bottom are the instructions that you will have to that describe what you have to do. Again, it's similar. If you get stuck, you can click the hide answer button, and it will help you out by showing the correct answer here. Yeah. Okay, before I move on, I would just want to see if you guys have any questions. Okay, so I will continue. The next chapters mainly deals with some specifics. So first it deals with some specifics of Node.js. The thing is that when you invoke a method of a smart contract, your application will exchange data with a DO node, and these operations are not synchronous ones. They are async operations, which means that they can take some time to complete. Yeah, it's not like when you are invoking a function that is running on your machine. Yeah, it's a little bit different. And for this, there is a pattern in JavaScript. It's called async await. It is described here. But the trick is that you cannot use an await function at the top level of a JavaScript file. Yeah, and for this you will have to use something called immediately invoked asynchronous function. The concept is described here, and we also provide an example. And the second part of this chapter will show you how to instantiate two of the classes that are provided by the Dion.js library, and namely it's the account class and the RPC client class. Again, we have examples here for each of them, how you instantiate them. And the last part describes exactly what you have to, describes what your response should contain. And you will have to type your response here at the right. Okay, so once we initialize the libraries, the text, the first step that you will have to do is to retrieve the list of top level domains. I assume that everybody is familiar with how the DNS name, how DNS works, so I didn't explain this. But for example, if we take a name like CryptoZombies.dio, the top level domain for that will be dio. And it's important to note that the top level domains are owned by the dio community, and you can only register names that end with one of the registered top level domains. I hope this makes sense. Yeah. And once you register a name like CryptoZombies.dio, you can also register subdomains. Like we give an example here, can be courses.cryptozombies.dio. Yeah. Uh, so in order to retrieve the list of top level domains, you will have to use the rpc.query method. We again give an example here of how this works, of how you instantiate a new object using the new keyword. And what you will do in this lesson is you will start writing a generic method that queries the blockchain. So you may ask why you need a generic method. The thing is that if you don't do this, you will find out that your code is a little bit repetitive. And the idea is to, you know, the concept of dry, don't repeat yourself, to avoid as much as possible repeating codes. And to do this, you will define a generic function called send query that takes three parameters. Is the RPC client an instance of the object that allows your application to interact with an DO node, the operation, which is the name of the function that you will actually invoke, and the arguments that will be passed to that function. Yeah. And similarly to the other chapters, we describe in details the code that you will have to write. Yeah. Again, if you get stuck, you can see the correct response here. Yeah. Before I move to the next chapter, I would like to stop a little bit. I know that probably the previous chapter was a bit dense, and I want to make sure that you guys don't have any questions.
There's no questions for now.
Okay, cool, awesome. I mean, I'm happy to means that everything is clear so far. So now, when you invoke the getRoots method to retrieve the list of top level domains, the response will look like this. Yeah. So if you think that this method will just retrieve a list, that is wrong. What it actually retrieves, it's an operator, which is it's an iterator, sorry, which allows you to how should I put it? It's kind of an interface that hides away the way in which the Neo blockchain stores data. Like you don't have to deal with the internal way in which this is done by the Neo blockchain. And it's kind of an interface that can be used by an application written in different programming languages, like in JavaScript, Python, and what not. Yeah. And what is worth mentioning related to the iterator is that it supports pagination to allow you to optimize your application and avoid retrieving a huge chunk of data when you make a call. And since this is a little bit complex, we kind of written two helper functions, which are called parse get root response and traverse iterator. This is just in order to help you out and kind of hide away all the complexity. And the nice part is that you can use these functions in your application. You can just copy and paste them and call them from your apps. And what you have to do for this chapter is inside of the getRoots function is to essentially call these two functions and store. And for parse getRoot response, you have to store the response that then you pass to the traverse iterator. The source code of the function can be found here. I mean, you are encouraged to take a look and make sure that you understand what these functions do before you start writing the response here. Okay. So should I proceed to the next chapter, or are there any questions?
I think you can. I think
Okay.
you can go to next chapter.
Okay. So the value that you got, the value that sorry, just give me a moment. So root, this variable now contains the response. So it's the data that was stored in the iterator, but now it's converted to an array. This is what the traverse iterator function does. And this array is comprised of a series of objects. Like, for example, it's the first field is called type, which describes the type of data that is being stored. For this function is byte array, and the value which is encoded, and you will have to decode it. What you have to do essentially is to call the base 64 to hex function and then hex string to string. It's all explained here. It's a little bit complicated, and I mean, I think that I'm not sure. I think that the explanation that we provide here it's clear enough, so I won't repeat it again. Okay, and once you do this, the last thing that needs to be done is to print the response that you retrieve from the neon node. And for this, we will use a string literal that essentially calls the function that converts the value from byte string to a string, which is a human readable value. Okay, so now I'll move to the next chapter. So once you retrieve the list of the top level domains and you printed them out, like when you run the get root function, you will see that it returns one item, which is .do. That is the top level domain that is currently registered. Then you can, the next step is to check if the desired domain that you would want to register is available. And for this, you will have to use the generic send query function, and you will have to provide it with the three parameter that I presented in the one of the previous chapters. It's an instance of the RPC client, is the name of the function that we want to invoke. So for this, the name of the function is available, and the params, uh, which is an array. Like you see, it's an array of objects, and the first field is the type. It's a string, and the values in our example is CryptoZombies.do. Yeah, and when you do this, it will return true or false, uh, depending on whether this domain name is available or not. Okay, and any questions so far?
Nope.
Okay, okay. So when you register, when you found that the desired domain is available, what you want to do is to register it, and for this you will have to pay a fee. And to understand how this works, it's important to mention that Leo, there are two tokens on Leo. One is the Dio token that gives the owners voting rights to participate in consensus and the decision-making process. And what is important to know besides this is that the Neo token is not the cannot be divided into smaller units. And the second token is the gas token, which, as the name suggests, is the utility token that you can use to pay for transaction fees to deploy and execute smart contracts. And the gas token is divisible up to 8 decimal places. So again, to register an example, to register a domain, we give an example of the parameters that you will have to define in our. One thing that is worth mentioning is that the price for registering a domain it's not the same, and the shorter the domain is, the more expensive it will be. And to find out what is the price for registering a new domain, you will have to pass to the API the length of the domain name that you want to register. Yeah. So in this case, we are determining the length using the JavaScript length function. And similarly to the other chapters, we will pass the parameters as an array of object. The significant difference here is that the type of the variable that we are passing, it's not a string, but an integer. Yeah. And sorry, it jumped to the previous lesson. And similarly, you can see the code that you will have to write. It's pretty simple. I mean, we already written the boilerplate code that is related to the commander.js library. That's you don't have to worry about it, and the only thing that you have to do is related to invoking the actual function. So you have to define the parameter that you pass to the send query function, and essentially that's it. Okay. Now, once you retrieve the price of the domain that you want to register, the next step is to actually register it, and to do so, there is a number of steps that you have to follow, which are listed here at the top of the lesson. You have to define the arguments to construct a new VM script, to build a transaction, to sign the transaction, to serialize it and broadcast it to the network. Luckily, most of these steps are pretty straightforward because the Neon.js library abstracts away all the technical details. And for example, for defining and structuring the arguments, which is what this chapter is focused on, you can use the contract param class. We describe exactly what this class does, what are the benefits of using it instead of building the parameters yourself. And we also give an example of how it works. And again, the way that we will go about this is similar to the send query function. So we will build a generic function that you can use. It will be called send transaction, and you can use it essentially to send all the transaction to the blockchain. And the only thing that it will change, so will be the list of parameters. Yeah, so it will be kind of similar with the send query function, but as you can see, you will also have to provide the account variable, which will allow you to sign the transaction. When you send a transaction to the blockchain, you have to sign it. It's not read only as in the case of the previous chapters. Yeah. I'll stop again here before I move to the next step, which is related to constructing a new VM script, to see if there are any questions.
Yeah, I think we can go to the next chapter.
Okay, so to execute a transaction, you will actually have to build something called the NeoVM script, which is essentially something that the Neo virtual machine can execute. So you cannot pass to the Neo virtual machine human language. It won't understand it. So what you have to do is to create a script that the virtual machine is able to execute. And for this, you will use again the Neon.js library, and more specifically, you will use a class named Script Builder, which simplifies significantly the process of building a script. This is an example of what you will have to pass is the script hash, the script hash of the contract that you want to invoke, the name of the operation, and the arguments. And this chapter is also pretty straightforward. I mean, we try to simplify it as much as possible, as you can see at the bottom right corner of the screen. What you have to do is to build arguments using the contract param class, and then you will have to invoke the create script function to build a script hash and store the script in a variable named script. Okay, I'll jump to the next chapter, which is related to constructing a transaction. And what is Neo is a little bit different from other blockchains that you might already be familiar with, is that it allows you, it introduces three concepts. They are called witness scopes and expiration height of a transaction. And this essentially gives you more freedom in terms of setting the level of authorization for signing and performing a transaction. So this means that from your end, you can specify that different transaction scopes that are described here. So the possible values are described here. They are none. This means that from your point of view, a transaction does not require a signature, is called by entry. This means that the witness must be explicitly invoked by the contract entry point. But it is important that to be aware that the witness scope is defined and enforced at the protocol level in DO. Yeah, and this determines essentially the level of authorization that you need to send and execute a transaction. And as I mentioned before, another aspect that is important, that is key when submitting a transaction in NEO, is the expiration height of a transaction. And this is essential, and this has two main benefits. I mean, when you define a specific validity for a transaction, is it helps expire a transaction. In other words, if a transaction has not been included in a block before the specified block height has been reached, it will be considered expired, and the blockchain will not execute it. And this allows for more efficient consensus, which means that the network can prioritize and process the transaction in a more efficient manner. I mean, transaction with shorter validity period might be prioritized over the ones with longer validity periods. Yeah. And again, in a similar fashion, to determine the expiration height, you will have to retrieve the current height of the transaction, which you can do by invoking the get block count of the RPC client object. And you will have to add the desired value to it. I mean, in this example, we are adding 100, which means 100 blocks, but this is kind of up to you to decide the validity period for your transactions. I mean, I know that this chapter was a little bit dense, and I would like to stop again and see if there are questions.
I think no, for now, we can move forward.
Okay, so I would like to ask you how much time do we have? So I have like 3 or 4 more chapters, and I think we have only 5 more minutes. Okay, never mind.
You can move on. I think the time is not necessary to think about. I think.
Okay, I see.
Great.
Okay, so the next aspect that is presented in the course is related to transaction fees. So when you want to register a domain, you will have to pay a transaction fees. And what makes Neo different from other blockchains is that in Neo you have 2 different fees. So one is the system fee and the other one is the network fee. The system fee is mandatory and you have to pay it for every transaction. It's typically paid in gas, and as you probably all already know, the amount that you have to pay is determined based on the complexity of the transaction. Yeah, and the second fee is an optional fee. Is called the network fee, and this is and its role is to incentivize the nodes to pick a transaction and process it and process it and similarly to the system fee, the network fee is also paid in gas, and also different from the system fees that you can set the network fee to whatever value you want based on your requirements and how fast you would want a specific transaction to be processed. Yeah. The code for checking the system fee and the network fee is a little bit long, and I didn't want to ask you guys to write the code in this course because this will take like 4 or 5 chapters for each of these functions and will make the course very long and maybe hard to follow. So we already filled in we created 2 functions, check system fee and check network fee. And we filled in the body of these functions. You can find them here. And again, you can reuse the code in your own applications. Yeah. So what you have to do for this chapter is just invoke these 2 functions, and they will print the network fee and the system fee. Yeah. Okay. And not sure. I will stop a little bit to see if there are any questions.
We can move forward.
Okay, so the next step, you remember we had a list of 6 steps. So the next step is to actually sign a transaction, and this will wrap up the send transaction function that we are building right now. So for this, you will need 2 pieces of information. What is the account, which is the signer that will sign the transaction, and the network magic, which is a value that identifies each of the different DO networks that exist. I mean, there can be a test net, main net, or you can even run your own net, and each of them has a different network magic. And for sending a transaction to the network, we will use the send raw transaction function, which is provided again by the RPC client object. And we explain all the details that you need to know in order to call this function. You see, we have an example and we explain all the parameters here. Okay, and the last step, so you've built the send transaction function, and you can use this function to call all of the methods of the NNS smart contract that requires you to update the state of the blockchain. I mean, you can call the set record method, the renew method, the set admin, or the transfer method that allows you to transfer a domain. We didn't ask you to write the code for all of these functions in this course because, again, it will get too long and you might get bored. But the last thing that we want to focus in this course is that you must ensure that you are performing error handling and input validation. And I mean, by no means we wanted to provide a comprehensive set of validation. We just wanted to give you an example of how to perform some, let's say, common sense validation. So for example, we are checking if the name of the domain that you want to register is an archi name. And we also verify that the name ends with Dio. Of course, based on your specific use case, you can add more validations. And the last part is related to error handling, which is kind of straightforward. So when you invoke a method on the Neo blockchain, it will return a response object, and what you have to do is essentially to verify if this value is null or not. Yeah, so when it's null, it means that everything went well, but when the value is non-null, it means that an error has occurred. And at the very basic level, what you can do is to print the error and exit the program. Of course, you can do more advanced logic here, but for the scope of the course, we wanted to keep it as simple as possible and show you the main concepts that you can use and build on them in your own applications. Yeah. Okay, and what you have to do in this final chapter is to perform validations and error checking for the functions that you call throughout your applications. Yeah, and this wraps up the course, the CLI part of the course. You can just to some ending words. I mean, you can register your desired name. You can use the test net. You have the URL here. It's testnet.neo.link. You you can also find it here. And if you want to register it through the web page on the mainnet, the domain name is neo.link. Yeah. Also, if you have questions or you want to find out more, we encourage you to join our for the developer chat and ask us any questions that you have. Yeah, and this concludes my workshop. I would like to thank you for bearing with me. I know that this was a long workshop and a long monologue from my part, and I just want to thank you for your attention. And Sam, if you have anything else that you would want to add or ask or whatever, please feel free.
Okay, thanks for your sharing, and I think the whole workshop is pretty clear. Um, and I think all the audience, if you have any questions, you can also ask them in the new Discord channel and the CryptoZombies Telegram group. And thank you, Audrey. See you all in the next workshop.
Cool. See you, and have a great day, and keep building amazing stuff. See you.
See you. Bye bye.